So, welcome everyone to this biomedical engineering session. My name is Ketul Popet. I'm the director of undergraduate programs in biomedical engineering. I'm also faculty in mechanical engineering. And a little bit background about me, I have been at CSU for about 14 years now. My undergraduate degree was in chemical engineering, and in those days, they didn't have a biomedical engineering program or even a double major program like what we have here. I would have chosen that. I would have chosen chemical engineering and biomedical, but there was no option like that. So I got my undergrad in chemical, and then my PhD was in biomedical engineering, and then I did a postdoc, and then I have been here for about 14 years, and my research is in the area of medical devices and materials. And I have been in this role as a director for more than a year now. I was interim to start with, and then now I am, the permanent director for undergraduate programs. So I hope you guys all come to CSU, and if you come to CSU, you will take the class that some of you just attended this morning, which I teach every fall.
So what Katul is saying, what Dr. Popat is saying, is that you're already one class session ahead of your peers if you end up choosing CSU. So my name is Robin Jeep Ernst, and I'm an academic advisor in the School of Biomedical Engineering. I've been working with the School of Biomedical Engineering for about 4 years now. So it's really cool. This is the first year that I get to see students that I started with, and they're starting to graduate. So it's a really neat experience for me. I advise all the first year students in our program. So all students that start in our program, I like to work with students in that first year to really talk about if this is the best fit for you, find ways to get connected to the school and to the college, to the university and at CSU. And so I work with students all in the first year, and then we have 2 other advisors that work with students from the 2nd to the 5th year. Actually, one of our other advisors is here, and so we'll create a dead space in a moment to see if she wants to introduce herself or if she is doing other things. We understand that as well. Oh, and there she is. So yes, so I'm an advisor again for the first year students. I am also a CSU alumna, which is a really cool experience for me to be able to share that experience. And have lots of experience on campus doing other positions. So when the time comes, if you have questions about CSU or about our program, please reach out to us. I will drop our information, kind of our email information on the chat so that you will have that. And then one other note for me is that because we are all living in this remote and virtual world, I have a small human that is my coworker today. So if anytime I need to step away or turn my video off, I'm not trying to not participate in the session, just need to respond to other things going on. So I'm going to take a moment there, and I will let Camille, if you would like to introduce yourself.
Yeah, hi everyone. My name is Camille Milo. I am a 5th year studying chemical and biological and biomedical engineering. So it's so nice to see a lot of familiar names. I saw a lot of y'all from the CBE session on Monday, so I'm glad y'all are here.
Cool. And Brett, do you want to just quickly introduce yourself?
Yeah, hi, and welcome to everybody. My name is Brett Epic Beal. I'm one of the other advisors. I work with 2nd through 5th year students whose last names start with I through Z. And it's really delightful to see you all here today. We hope this is useful, and we're really glad you're considering the BME program here.
Okay, so we have a short presentation. We have prepared some slides, and I'm going to share the screen in a minute and then talk about our program. And I'll talk in the beginning about a few things, and then Robin would, talk about a few more things, and then, we'll let you guys ask questions that you have, and and we'll be happy to provide any information that you need or any questions that you have. And for some reason, if you don't have any questions now, but later on, as Robin said, she's going to share our contact information. You can always email us, and we can set up one-on-one sort of Zoom meetings to talk more about any questions that you have. So, okay, so I'm going to share my screen, and let's see. Share. Okay. Okay, can you guys see my screen?
I do.
Okay, great.
Yep.
Okay, great. So as I said, my name is Ketul Popat. I am the director of the undergraduate program, and I'm also a professor in mechanical engineering. So biomedical engineering is a very unique field. It's one of those fields. Well, let me talk about what we do first of all. Well, the main goal in biomedical engineering is to improve the quality of life of people. And that can be done in many different ways. That can be done by developing medical devices, that can be done by developing new pharmaceuticals, that can be done by developing new ways in which we cure disease. So overall, the theme is that we want to improve health and we want to improve the quality of life of people. Now, a lot of the things that are done in biomedical engineering has been done in past through different fields. For example, in medicine, people have been doing this exactly what I mentioned. Biology, there's a lot of research going on that deals with human health. But adding engineering to this gives a whole different perspective, because as an engineer, you are going to build things, you are going to design things, and it's the engineers who actually bring things to market. So biologists, people who are in biology, they would do research, but what comes to market and what is being used by patients, that's all built by engineers. And that's where biomedical engineering comes in. And you can see this cartoon here that engineering is an integral part of a lot of things that happen in the human health field these days. Later on, we'll talk about sort of a few different examples of how engineering is involved. But the field of biomedical engineering is very multidisciplinary, which means that you need people with many different backgrounds to be able to solve these problems. We are also solving global problems. We are not solving local problems. And as we are going through the situation right now with the pandemic, we know that it's a global problem. It's not just isolated local problem. And so we need expertise from many different people. And the biomedical engineering degree kind of gives you that flavor. It kind of gives you the feel of how engineers can be involved in different aspects in the human health field. But from a learning perspective, as a biomedical engineer, obviously you will need to know some biology. You will also need to know some science. Science fields such as chemistry and physiology and math. Math is important. You guys might think, why is math, what math has to do with human body? As a matter of fact, math has a lot of things to do with human body. So it's a very important field in biomedical engineering. Um, you know, in the medical field or in medicine, how that's involved is basically things such as, how we can prevent medicine, how we can prevent diseases, how we can diagnose disease, how we can create therapeutics to solve diseases or cure diseases. And then the engineering part of this is basically where the creativity comes in. As an engineer, you build things, you design things, you make your hands dirty and build stuff and test stuff before it actually goes in the market. And so engineers are very heavily involved in the health field. Some of the engineering disciplines which are very important, and this is just a short list. I mean, there are many different engineering fields which have very much sort of involvement with human health. But here at CSU, our program is a very unique program, and I'll talk about that in a minute. But chemical engineers are involved, electrical engineers are involved, mechanical engineers are involved, material scientists, physicists, chemists. There's so many different people are involved in this field of human health. So some of the things that biomedical engineers do, and this is just a very short list of what biomedical engineers do. Biomedical engineers are involved with instrumentation, building up instruments that actually helps medical people to diagnose disease in a better way, or to know that the disease is progressing or not progressing, and then design ways or figure out ways in which we can prevent progression of disease. That's all part of biomedical engineers, and biomedical engineers are involved in that. Biomedical engineers are also involved in the field of biomechanics. I'll give you a very simple example. Designing shoes that people can wear and run better. That's actually biomedical engineering. There are a lot of special fancy, shoes that you can see that, people buy because that helps them to run better. The design of that is all done by engineers. Point of care diagnostic, this is something which is really big and it's going to become bigger, where you want to actually diagnose a disease right at the patient's bed, or you want quick diagnosis of certain kind of disease so that you can start the therapy right away. Robotic surgery is really big right now in biomedical engineering. You want to actually do surgeries in a very precision way. Not that surgeons can do it in a precision way, but if you have robotics, you can do minimal invasive surgery, so you don't have to open up a lot of the body. You can do minimal invasive surgeries, and they can be done in a very precision way. So a lot of exciting things that biomedical engineering professionals are involved in. So here at CSU, our program is actually one of the most unique ones in the country. Two Bachelor of Science degree. And the reason why we have the program set up that way, because we had a lot of feedback from the industry, which basically mentioned that they need students, they need professionals who graduate with multiple different experience. So they would like that they definitely know about the biology part of biomedical engineering, but they also wanted people who would know, things like how to build, how to do 3D printing, or how to make instruments, or how to design drugs. And so that's why we have this program where you get a degree in biomedical engineering, but you also get a degree in mechanical engineering or electrical engineering or chemical and biological engineering. So it's very much sort of industry driven. A lot of our students who graduate and go to industry, they find this combination, this dual degree program very valuable, because they are very much ahead of a lot of their other peers who just have a biomedical engineering degree, because they also have another engineering degree. And so we almost have this T approach kind of a thing, which is shown in this slide, where as a biomedical engineering student, you will definitely be taking courses in science, so physiology, organic chemistry, biology. You will take those kind of courses. You'll also take some physics related courses such as statics and dynamics. You'll also do a lot of math. You will do a lot of core curriculum from the university. So, things like technical writing and, those kind of courses. And then you also do a lot of biomedical courses. And, we have our senior design, which is actually one of the best experience that students have, and Camille actually is in senior design right now. So she can tell you more about the exciting things that seniors, when you become seniors, you'll end up doing. And we also have like a gateway course, which is sort of a hands-on course that you take in your third year, where you can use ultrasound machine and take images on your own, or you will take an ECG and those kind of things. So we have a lot of courses which are sort of designed very much to give you that hands-on practical experience, but also there's a lot of problem-based learning which is incorporated into our courses, where you work on a project, you do a presentation, you work as a group, because that's actually a very important part of being in this biomedical engineering field, because we always would need a group effort to come up with solutions to these medical problems. And then you also end up taking partner major courses, such as if you're in chemical engineering, you will take courses related to mass transfer, and you will take fluids. And if you're electrical engineering, you will take circuits and things like that. If you're mechanical, you will take things like thermo, and you will take heat transfer. And there's a lot of different types of courses you would take that would prepare you to go out in the field and get the kind of profession that you want to go in and get the kind of job. So our degree is a 5-year program. It's approximately 157 credits, and you do get 2 degrees at the end of your 5 years. So the degrees that you get is Bachelor of Science in Biomedical Engineering, plus you get Bachelor of Science in Chemical and Biological, or electrical with a concentration in laser and optics. That's actually a specialization that you can do. And there's a lot of interesting, industrial applications of lasers and optics, especially microscopy and, laser related surgeries and things like that. So it's a pretty exciting sort of a specialization you can get into. And then you are also or you will get a degree in mechanical engineering. We strongly encourage that you apply early. We would want all of you to come to CSU. But we would strongly encourage that you apply early, especially the ones who are thinking about mechanical engineering, because mechanical engineering has some caps and some control. So the earlier you get your application in, you have a better chance of getting into that program. Now, one of the things that students always ask, like, I'm getting 2 degrees, is it really going to pay off later on? Well, yes, it is. You can see some of the statistics here, which are from the Bureau of Labor. Biomedical engineering is expected to grow 5% in the next 10 years. And the feedback from the industry is very much on sort of the biomedical engineering, sort of the depth of biomedical engineering. And what we believe, and we strongly believe, is that our dual degree program kind of gives you that depth in one of the engineering fields, but also give you that breadth that you need in the biomedical engineering, in the medical field. So you do have a lot of depth courses that you would take, and you would get trained in the depth part as well, but you also get trained more in sort of the broad aspects of biomedical engineering. So we're going to have a pop quiz, and I hope that people would actually try to participate. So I'm going to show a picture. Does anybody know what this is? And I can see a lot of hands raised, but if you just want to speak up, somebody who wants to speak up, that's fine. Anybody? Don't be shy.
Is it possible to get a dual degree in 4 years rather than 5?
So we'll talk about that in a minute. Let's go through the slides first. And definitely that's a very good question, and we'll talk about that. But I wanted to see if anyone can tell me what this picture is.
And we've got an answer in chat. That's Owen says hip joint question mark.
Perfect. It is actually a hip joint. And as you can see, it's actually made up of metal. And a lot of the processing that is actually involved to make this, it's actually mechanical engineering processes. Mechanical engineers have been very much involved in development of these kind of implants and prosthetic devices and processing of materials. And this is a very good example where you have a joint, and that joint should be very smooth, right? You'll have a lot of junctions in machines and things like that mechanical engineers build, where you can't have, you have to have smooth sort of, joints and things like that. The same principle applies here, but this is now for a medical application that saves people's lives when they get these hip implant. Let me put another picture here, and just tell me if anybody knows what this is. You can type in the chat as well. Any guess? Come on, this is very easy. Anybody typed in the chat, or?
Owen's on it. And we've got Owen and Devin both answered pacemaker.
Perfect. It is a pacemaker. And pacemaker is a very interesting device because, obviously you can see it's made up of materials and things like that. So obviously mechanical engineers are involved in this, but the principle on which it works is very much electrical engineering principle, because you are trying to provide really small amounts of currents to maintain the rhythm of the breathing, or the rhythm of the heart. So yes, and this is something where a lot of electrical engineers are involved. And again, when I say electrical engineers, when I say just mechanical for hip, doesn't mean they are the only ones. There are many other people involved in design of these kind of medical devices, but primarily the mechanical engineers have been very much influential in these hip implant design, electrical engineers in this pacemaker design. The last one, let's see if you can get it. It's pretty interesting looking medical device. Anybody has a guess? I don't know if you can zoom in. I can read the name of the manufacturer on the side, but I don't know if that gives a clue to somebody what this is. I think, Robin, you are mute.
It's just funny to watch everyone kind of like look into like the.
Well, you have to go really close to your screen to see it, but I think you can see the manufacturer. Anybody? Any guesses?
We've got a guess from ONG saying artificial heart question mark.
Not really. Not exactly.
Lung question mark, stomach question mark.
No, it's okay. This was a hard one. So if you don't know, that's fine. That's okay. This is actually a blood oxygenator. And so typically when people go through open heart surgeries and then they have to stop their heart and connect them to like a heart lung machine, they need to oxygenate the blood that's going in. And they use a system like this, which has membranes and things like that. And the oxygen gets added in the blood and the blood is circulated through the heart lung machine. So this is where chemical engineering principles are involved. Now, there is a membrane system, and chemical engineering, there's a lot of things that you do in chemical engineering is related to separations. And so the principle here is very much same as that, but the application is very much focused in the medical area. So what do our graduates do? Well, here is a chart that talks about our undergraduate alumni and what they have been doing. So you can see that some of them are going to grad school, some of them are doing some other engineering work, some of them are BME related, some of them are exactly they're doing like what they got the degree in. We have some people in non-engineering fields as well, and here are some of the sort of the companies that hire our undergraduate students. So Terumo, which is a big company here in Colorado, Medtronics, Beckman Coulter, there's a lot of companies that come when we have career fair. A lot of our students actually do internships. A lot of students, they continue in the same company, they get employed in that same company after they do internships. And overall, we have got a very positive sort of feedback from students about this 2-degree approach because it opens up a lot more opportunities for you. You're not sort of restricted to one field, but you have many more opportunities than what you would have. Robin, do you want to go ahead and should I unshare, or I can just run the slides if you want me to?
That's totally fine. You can just keep hold of the slideshow. So actually, yeah. I made a typo in here, and I did update these slides for the incoming class of fall of 20. But really just to kind of show you all that we have a great diversity in our program. And we typically have our program, it kind of runs at about, this year it was 49% women. And we've seen that number up to about 56% of our program is women on any given year. So this is just the incoming class, not the entire class. But we have a great diversity in our program. Not too many programs in engineering can highlight that amount of percentage of women in our program, in their programs. So this is something that we really are proud of, or excited about, that our major does, it encourages students from kind of all walks of life. So we also have about a quarter of our students are from out of state. About a quarter of our students identify as culturally diverse. We have 12% of our students are first generation students. So students who neither parent have graduated from, who have earned a bachelor's degree. And then we have about a quarter of our students are honors students. So participate in the honors program and kind of have additional research kind of portions of their degree. And all of our students, and this is again the fall class, but all of the fall 20 class is very high academic performers. So GPAs of over 4.0, high SAT scores and ACT scores. And if you're looking at those numbers and thinking, oh great, that kind of identifies me, or you're looking at those numbers and thinking, I don't know if that identifies me, this just shows a range of kind of where we see our students coming from. So don't get too hung up on those numbers. We also have a lot of collaboration in our program. We collaborate with 60 faculty members from 4 different colleges around the university. So we've got lots of great minds and great perspectives that are part of the School of Biomedical Engineering. And then we've got facilities on the main campus in both the engineering building and the Scott Bioengineering building. That background picture is the Scott Bioengineering building. But we also have facilities in the Engineering Research Center on West Campus, as well as the Vet Teaching Hospital and the Animal Care Center, which is kind of on the south end of campus. We really want to highlight that there's lots of opportunities for students to get involved beyond the classroom. So we have a lot of students that get involved with internships and cooperative education experiences. And we will have some of those students that have had some of those experiences in the panel coming up next. So that would be a great time to ask some of those questions. Dr. Popat really did talk a little bit about some of that senior design and getting some really practical experiences. And on our website, we've got some great videos of some of the senior design projects that were presented last spring. So if you want more information, going to our website can be a great source of that. A lot of students do get involved in research and participate in labs. And depending on the timing that we have in a little bit, we can show a couple of videos from some of our students that are currently participating in some research. Another way for students to get involved is through student organizations, and we've got a great group called the Biomedical Engineering Society. It's kind of a student-run campus organization that's part of the larger Biomedical Engineering Society. And it really is a great way for students to get connected with others, meet faculty, learn about biomedical engineering, as well as potentially participate in the annual meetings. We also have a lot of local and global collaborations. The vet school, we've seen students go work down in the Denver Health Center, as well as we've got lots of faculties that have connection kind of around the world. And I want to highlight for a minute some of our study abroad experiences. We certainly have students that study abroad kind of in this longer term, maybe for a semester, and have gone to places like Australia and New Zealand, as well as Edinburgh in Scotland has been a couple range study abroad opportunities. We have a really cool partnership with a program called ROMP, which is the Range of Motion Range of Motion Project, where students will study abroad in Ecuador. And the next slide, if you want to go ahead, Dr. Popat, there's a little bit additional information about this opportunity. So this is a program that's specific to biomedical engineering, though anybody can join in, but it really is about biomedical engineering, and the program is really specific to prosthetics. So learning about prosthetics. So it's a shorter term study abroad opportunity that happens in May, kind of after the academic year. And so it's 9 days, and it happens in Quito, Ecuador, where students go to Quito, Ecuador and spend those entire 9 days working on prosthetics, fitting prosthetics, working with individuals who are in need of prosthetics. In one of the experiences, there were students that were working on kind of how the individuals who are receiving the prosthetics were using them, and how they were fit. So it's a really, really neat opportunity for students in biomedical engineering to really get that hands-on experience. We've had students that have gone on this that have any of the partner majors. So we've had students that are in mechanical engineering and electrical engineering and chemical and biological engineering, and all of them have really kind of talked about the value of the program, as well as kind of really learning about prosthetic devices and medical devices by being a part of this experience. Dr. Popat talked a little bit earlier about kind of our program and its uniqueness, but we are the first accredited biomedical engineering program in the state of Colorado. And we are the first accredited biomedical engineering degree that has that dual degree approach. And it's by the program called ABET, or the Accreditation Board for Engineering and Technology. So we are ABET accredited. And if you want to learn more, I can put this information in the chat in a little bit. And again, if you are still around in about 30 minutes or 25 minutes, we're going to do a panel, and that's a really great way to learn a little bit more about our program. So let's take a moment or a pause and see if there's any questions from any of you. You all can, put a question in the chat, or if you feel comfortable unmuting yourself and asking the question.
Yeah, and we already had one question, so we could go back to more questions, and we'll be happy to answer whatever questions that you have. I always tell students when I teach, like, there is nothing called a not important question. Every question is important.
Absolutely. And Owen, you had asked a question in the chat kind of about, that it's, and you can correct me if I'm wrong in terms of what you're really trying to get to. But asking about our dual degree program is a 2-degree approach with mechanical engineering and biomedical engineering. And in your question, is it a little bit, your question, is it about if you did a mechanical engineering with kind of a focus or concentration in biomedical engineering? Is that kind of what you're asking? So have like your primary major in mechanical engineering with the concentration or focus in biomedical engineering? So let me answer that question, and Owen, if you want to clarify that in the chat, that's great. But yes, in some ways that is an option. The easiest answer is to say yes. And then beyond that, kind of the technicalities is that though the mechanical engineering program does not specifically have a concentration in biomedical engineering, you could do a mechanical engineering major with a minor in biomedical engineering. So we do have offer that minor in biomedical engineering, which is neat because it's a transcripted piece as well. So you have that kind of transcripted option with a biomedical engineering minor. I think that the main difference that I see in doing the 2-degree approach versus the minor is that the amount of hands-on experience that you're going to get in the double degree is really going to be a lot more extensive rather than the minor. The minor does not require those hands-on courses, though they would be options, but it doesn't require them. So
yeah, and also like our senior design. So the biomedical engineering senior design that you guys will do is truly on industrial projects. It's truly on projects where a company would say, well, we have this implant or we have this device and we want to improve it. Then you break it apart and you see how it works, and then you suggest them new ways in which they could improve it. So your projects as a senior in your senior design would be medical projects, would be sort of these hands-on projects on real problems. And I mean, mechanical engineering also has a great senior design, but it's very much focused on the mechanical aspects and not so much on the health aspect. I would say rarely on health aspect, it's mostly on the mechanical aspect. So that would be the big difference between just a standalone degree versus a dual degree. So we have a couple of questions as well. So we have a question, is there prosthetics research? Yes, definitely. We have people so the way it works with biomedical engineering faculty, they're all part of another department. Like I am in biomedical engineering, I am the director of undergraduate program, but I'm also professor in mechanical. And so we have a lot of professors like this in mechanical who are doing prosthetics research. And they're doing research on the materials aspect, they're doing research on the mechanics aspect, because just materials is not enough, right? You need to make sure that the prosthetics are stable and they would last longer and they can withstand forces and things like that. So yeah, certainly there is a lot of prosthetic research that goes on. Robin, I don't know if you are aware, I know we have students who are in athletics, but I really don't know how many. But I know I always get emails from the athletics department that we have these students in your class. So.
Yeah, so Alexia, you asked a question about if anyone is also involved in athletics. And if you want to clarify in the chat, you absolutely can. I'm not sure if your question is referring to if we have students who are student athletes, or if we have kind of research and opportunities that have to do with athletics. So you might want to, if you have a clarification question, you can type that in the chat. But we do have student athletes that are part of our program. Again, our program does really attract a lot of students who are interested in movement and human body. And so it does naturally attract a lot of students who are athletic. In terms of maybe answering kind of the other side of the question, okay, then hopefully that did answer your question. And if you ever want to contact me personally and kind of ask questions about if you are wanting to be a student athlete, or if that's your plan and kind of how this works together, please do that. And as well, right, so kind of answering the other side of the question, are there are there research opportunities having to do with athletics? And what we really encourage students to do, so there's no direct answer to this, but what we do encourage students to think about in terms of getting involved with research is to not limit yourself to only engineering faculty, but really to open up your opportunities that go across all of our kind of those 4 colleges that we partner with. And beyond that, to do research that really seems interesting to students. So if there is a particular researcher in maybe the health and exercise science major, then I strongly encourage students to get involved with those types of.
And we do have actually students who are currently working in health and exercise science department faculty research, so it is absolutely possible. We even have students who work with researchers in psychology, so there is no, there's no boundaries. You guys can work in any kind of research area related to human health in any department or any colleges on campus. So Owen's question was about those concentrations. So the mechanical engineering offers 2 concentrations. Well, one is for sure, it's the aerospace concentration, and the advanced manufacturing concentration is coming up online, but there is no biomedical engineering concentration. Now, here is the thing. So if you enroll into mechanical biomedical program dual degree, there is always a way you can take the courses which are related to aerospace, for example, and do a concentration in aerospace. It gets a little bit, so again, this becomes very specific, very, very unique to you. And, when students are interested in something like that, we talk to them, we advise them the right way so that you take the right kind of courses and things like that. So, once you're here and, once you can take any classes that you are interested. You must take 157 of what's given, what is needed for the degree, but that doesn't mean you cannot take more if you wanted to, and some students do that because they really want to gain that experience, and they do that. So certainly, there are possibilities like that, and we try to do this on a one-to-one basis and kind of discuss, that what makes the sense for a particular student, and advise them that way.
And a small piece of clarification too is that as a biomedical engineering major, depending, kind of in some ways, regardless of what concentration you choose, you will earn the full degree in biomedical engineering plus the full degree in your partner major. So you will be taking the same exact courses that all mechanical engineering majors take, that all electrical engineering majors take, that all chemical biological engineering majors take. There's no difference in that. So you may have a friend who is chemical and biological engineering only, whereas you're doing the biomed side. You will still take classes with those students, and then you'll take the additional biomedical engineering.
Yeah, and for everything that matters, when you graduate, you will be a mechanical engineer and you will be a biomedical engineer. So it's not that either or, you'll be both,
And that is one of the highlights of the program, is that you do have both of those degrees, so that when you go into the world of work, you are not only a biomedical engineering major, you are also your partner major, right? So you have those kind of 2 identities or 2 hats that you can rely on. We have a couple questions here about both Lauren P. and Nick G. asked, is this degree a good fit if you wanted to go in the pharmaceutical industry and not decide a process or mechanical engineering? And absolutely.
Absolutely. Yeah.
This is what we find is that a lot of students will choose to go the route of chemical biological engineering to really understand that depth of chemistry and how that impacts biological systems. So kind of that biochemistry piece. And so we do see a lot of students who choose to go into the pharmaceutical industry and work on pharmaceuticals. So
yeah, and this degree, biomedical degree, gives you that medical flavor. It gives you the sort of the medicine part of the perspective. Chemical engineering is a lot about like making chemicals and purifying chemicals, and a lot is involved in that, but the biomedical piece kind of gives you that medical relevance to what you do in chemical engineering. And Camille, I think, is a CBE, CBE biome. I don't know if you have anything more to add, Camille, than what we just mentioned.
Yeah, so CBE is actually a really great major to take if you're interested in pharmaceuticals. Specifically, you'll start to go into that realm of biomedical engineering your 4th year when you take a class called Transport Phenomenon. So this class will be able to help you understand how to essentially model how things move within different compartments of your body. And yes, that's a little bit more general in terms of like, for us, we looked at how different toxins go into different compartments and different organs, but you can look at that into how medication can flow from different parts of your body. And so that's where you'll start to get into that side of biomedical paired with chemical and biological engineering. And then in your second semester of your fourth year, you'll also start to kind of learn about the equations that have to do with understanding why certain substrates attach to certain enzymes and all those cool things. And so kind of going back to one question and also answering this question, a way that you can go ahead and kind of gear what you want to do with this degree are with classes called technical electives. And so, Owen, to kind of go back to also to your question about the concentrations, if you're interested in kind of the different concentrations, you can take those technical electives to kind of fit whatever concentration in mechanical engineering you're interested in, or if you're interested in that pharmaceutical industry, you can take a class called pharmacology. And I know they offer that in the spring because I want to take that next year. But like I said, these are all classes that you can take to be able to gear what you want to do. And what's really cool about doing this dual degree is I believe you get 3 of those technical electives. And what's really nice is that they kind of overlap with each other. So you have some stuff for biomedical engineering, but you also have technical electives for that partnering major. So yeah, you can also look into those, and I'll go ahead and drop some of those dual degree links that will show you those technical electives, and you can kind of scan through them and see if those were for what you're interested in.
So we have one very good question. I'm glad somebody asked this question. So thank you, Alexia, for asking this question. So if you're transferring from a 2-year program or having an associate's degree, is it a smooth transition? Absolutely. Absolutely. It's a smooth transition. If you have done a lot of courses, we can, and what we do is we try to map your courses to what we have here at CSU, and we try to find the equivalency of the courses, and then you transfer all those credits, and then you just start taking the ones that you have not, and then continue, moving with your 3rd year, 4th year, and 5th year. So absolutely, it's a smooth transition. Yeah. I don't know, Brett and Robin, do you have anything else for transfer stuff? I know that on our side, Alexia and other students who are here, we have been working really hard to make sure that our transfer students have a very smooth transition when they come to CSU. And we would like you to come to CSU, and we will give you credit for equivalent courses. Absolutely not a problem. I know there was a question earlier about, somebody had asked about, can you finish this in a 4-year versus 5-year?
And before we move on, I think Brett had a comment on the transfer.
Oh, sorry.
Yeah, it actually can segue into what I think you were just about to talk about. Since I'm guessing you are all kind of also in high school, this may not be as much of an issue. But sometimes there's a little bit of confusion that, yes, we absolutely want to make sure that a transfer experience is smooth and valuable, that you feel connected and all of that kind of stuff. But remember that engineering is very sequenced. So occasionally we get students that have a ton of credits, but none of them really fit for engineering, which is great. They makes you a better person. Doesn't fit in engineering. But then you'll still need to take all those sequencing. So just remember that. So as it relates to compressing the degree, I'll pop it back to Dr. Popat for that. If you have questions about credits transferring, you can always talk to the Office of Admissions, and we'll make sure that we can give you as much credit as possible.
Yeah, and the question was, can you do that in 4 years? Well, you may not have the full experience of it. Let's say if you come from as a transfer student with an associate's degree, which is also in engineering, and you have taken a lot of math and physics and chemistry and some design courses, certainly I think then you can finish sooner if you have a lot of those transfer credits. But normally, you have to think about this. These are 2 degrees, right? So if you actually had to do 2 degrees separately in a different university, it would take 8 years. Whereas here you're trying to get 2 degrees in 5. So I think it's already a bonus that you can finish these 2 in 5, which normally would take 8. No matter which university you go, it's going to take 8 years. So anyways, it's a shortened path to get 2 degrees. And I think to truly experience, and as I talked about the senior design and a lot of hands-on experience and research in the lab and all these things, you really need to spend some time. And our students who have, and Camille can, probably say, I see her nodding, so she agrees with me that, we really, you really need to spend that time and get and immerse yourself into your classes in the lab, in all these professional social activities. I think you really need that time to spend time. You need to spend that time to know the field and to know what you exactly want to do after you graduate. But as Brett said, there are circumstances where you you enter with an associate's degree, certainly, and if we can find equivalency for the courses that you have taken to CSU courses, we can certainly do that. Yeah, you can certainly transfer those credits and you can get benefit for that. Yeah.
And Owen, I see that you have a question about how many credit hours per semester you need to graduate in the 5-year dual degree program. And Camille put those links in there, which is a really helpful way to kind of see the kind of plan or semester by semester plan for graduation. But it kind of averages anywhere between 15 and 17 credit hours. And that also will depend on how many credit hours you come in with or you transfer in with. This is kind of a piggyback of what Dr. Popat is saying in terms of the timeline and the experience, is that we do get a lot of students, again, that come in with those transfer credits, either by going to a different university or by having a lot of AP credits or IB credits or dual enrollment credits. And what we find is that that can really help not necessarily shorten your degree timeline, but really make it so your semesters aren't quite as rigorous. So if you're coming in with some of those credits, instead of the answer being, 15, 16, 17 credits every semester, the answer might be more in kind of 13 or 14, which for some students becomes more manageable and more opportunities to get involved kind of outside of your academics.
I would like to just piggyback on what you guys were telling me earlier. So I am transferring from a junior college, so I am in my 2nd year. So I'm taking the Calc 1, Calc 2, currently taking Calc 3 classes, like stuff like that. So I just wanted to know, and like biologies and chemistries. And so transferring in, you kind of talked about how I would be able to like get more involved with what you guys have to offer, since I do kind of have those big classes out of the way.
Yes,
Absolutely.
certainly. Yeah. Go ahead, Robin.
Yeah,
Sorry.
definitely. And Alexia, please take note of my email address. And if you have particular questions about that process or what it may look like, or if you want to kind of even go over your academic plan, I would be happy to do that with you before you finish your before that transfer process. But what we do find is that it'll give you that space to kind of make your semesters more manageable. And what we see sometimes with transfer is that depending on your partner major, it may mean that you come in with 2 years and you kind of have 3 years remaining, or it may mean that you come in with a credit for 2 years, but in terms of the sequencing of courses, it may mean that you're at CSU for 4 more years, and then have maybe less credits each semester or more time for involvement.
Okay, perfect. Thank you.
Yeah, you're welcome, Alexia.
So, a lot of our students also do research, and I know we probably don't have time to kind of share or show you the videos of the research, but maybe we'll put a link in the chat. So our students are very much involved in research, and they work during the semester, during summer in research labs. They are involved in a lot of research activities that goes on, and then our students also end up presenting their work at various conferences. Just last week we had Biomedical Engineering National Conference. It was virtual this time, but we had some undergrad students who presented their work there, and we also have students who present their work on CSU. CSU has a lot of undergraduate research conferences as well, and many other conferences. So we wanted to share, and I know Robin just pasted, put the link. So whenever you guys get a chance, please look at that. These students are talking about the exciting things that they're actually doing in the labs.
Great. I think what we're going to do at this moment is probably close this. We're not necessarily going to close the meeting out, but we're going to stop this recording for this session, for the informational session. This is the same exact link that we're going to use for the next session, which is the student panel. And so for those of you that want to just continue on in this session, that's fine, and not leave the meeting, that's absolutely fine. I'm going to take a minute and turn off my video and my the sound and just take a 5-minute break. So basically what we'll do is we'll